Now, welcome back again for our lesson in year 9. Today, we're going to be looking at the types of mixtures. Types of mixtures. Just a recap. In our previous lesson, we looked at the fuels. We talked about the hydrogen fuel and how it works. We had also looked at the other types of fuels. And then, prior to that, we had looked at the atmosphere and the composition of the atmosphere, where we have the gases, nitrogen at 78%, oxygen at 20 to 21%, argon 0.9, and very many other different components in the atmosphere. Now, implying that if all these particular substances are not interfering with each other, then it means that the atmosphere of the air is actually a mixture. So today we are going to specifically look at the different types of mixtures, because we only looked at one part, but we were looking at the atmosphere not in line with it as a mixture, but in line with it with the composition. But now we want to look at the different types of mixtures. The objective of our lesson is that at the end of the lesson is that we should be able to explain the different types of mixtures. Giving examples in each particular case, we should be able to explain the different types of mixtures. When we talk about the different types of mixtures, this is very important because it also informs us on how we are able to separate the mixtures. The method of separation chosen also will depend on the type of mixture. Now, we have 4 different types of mixtures. We have got 4 different types of mixtures. These ones are solid mixture. Maybe I can put them down. We have what you call solid mixture. We have solid liquid mixture. We have liquid mixture. And then we have gas mixture. Solid mixture, solid liquid mixture, liquid mixture, and gas mixture. If you look at the 4 categories, you discover that all the 4 are only mentioning about mixtures in the 3 physical states. Either a mixture will be involving the solids, the liquids, the gases, or their mixtures. When I talk about the mixtures, for example, we have a solid liquid mixture. That's a mixture of the solid and the liquid. So we can have solid, liquid, and then gas. Therefore, the method of separation chosen normally depends on the physical properties of the components of the mixture. That means that each particular component of the mixture has its own physical properties. Every section of the mixture has its own properties. So because of that, then, when we are deciding the method of separation, normally we look at the physical properties of the different components that form the mixture. Then the physical properties which will make them easily be categorized into 2 will be the one to be used in separating the 2. I'm saying this because when you're looking at, for example, solid mixture, it normally has 2 solids together. So it means their physical state is the same. So it implies that the separation will be a bit tricky to be able to pull them apart. So there must be something else that will be able to help you now differentiate the 2. That's why we're talking about the physical properties. We shall be looking at some of the physical properties in some particular selected examples that we'll be using. Now, apart from the physical properties, the separation can also be done based on the differences in their densities or the densities of the substances that form the mixture. Which means apart from the physical property, we can also employ the differences in the densities. Densities of the components that form the mixtures. Implying that we can have a mixture. Let's say a solid-solid mixture, solid-liquid mixture, liquid-liquid mixture, or gas-gas mixture, whose components have different densities. We have a liquid with this particular density. One liquid is higher, the other one has a lower density. So it means we can take advantage of that, then select the most suitable method that we can be able to use to separate such a mixture. Now, maybe before we look at the methods and the different types of mixtures as separated, we need to look at some specific aspects of physical properties. A solid that dissolves in a liquid and a solid that dissolves in a liquid is known as a solute. We refer to it as a solute. And then the liquid mixture that is obtained when a solid dissolves inside that particular liquid is known as a solution. Let's say if you take salt, which is a solid, then add it into water, then you stir. Whatever is obtained becomes a solution. But that solution, if tested, you discover that it's a bit salty. If you take sugar into water, then stir, you discover that the sugar dissolves in the water. So that sugar dissolving, that sugar crystal dissolving is known as a solute. Then the liquid that results after the sugar has dissolved is the one we are referring to as the solution. Now, the liquid which dissolves the solid is known as the solvent. Tricky, we have the solid dissolving in the liquid, solid. We have the solution obtained, or the mixture obtained once the solid dissolves into the liquid, known as a solution. Then we are also looking at now this liquid which is allowing the solid to dissolve in it. Let's say, for example, if you have sugar and water, this water allows the sugar to dissolve in it. So water in this case is known as the solvent, the sugar is the solute. So if you have the solute plus the solvent, you will get a solution. Solute plus solvent, you will get a solution. And this is specifically for solids that dissolve in water. We have some that do not dissolve in water, and some can dissolve in water. So the first aspect that we use in our discussions when it comes to separation of these particular mixtures is the probability or the chance of a particular solid to dissolve in water or not to dissolve in water. If you have two solids forming a mixture and one can dissolve in water, another one cannot dissolve in water, then the best thing is to use water. Add the water to the mixture, stir. The substance that dissolves in water will dissolve. Then the one that does not dissolve in water will not dissolve. So you can be able to filter off to remove the one that does not dissolve. That's the easiest way of separating such kind of a solid mixture. Now, in some cases, a liquid which completely mixes with another liquid is said to be a miscible liquid. Miscible. Most of us normally look at the solids. You hear of the mixtures, we always talk about the solids. But you also have mixtures which involve the liquids. And we say that in some situations we'll have two different liquid substances which can come together and result into formation of one uniform layer. One uniform layer. Then such is referred to as a miscible liquid. For example, if you take ethanol and water then you put them together, both of them mix completely and they still remain colorless. Don't even go to ethanol. Take milk and water. What do you observe when you add milk to a cup containing water? Obviously, it all remains white. And if you look at it, you'll never see where the water has reached and where the milk is. It means the two of them mix completely, resulting to formation of one uniform layer. The uniform layer in that case is the white uniform layer. So milk and water are the ones that we're referring to as miscible liquids. We refer to them as miscible liquids. So we have water and ethanol. We also have milk and water. Now, when we have some liquids that can mix uniformly, we have some that do not mix completely. Even if you are to stir these two, for example, if you have oil and water, the two do not completely dissolve. Even paraffin with water, if you put the two together and then you stir, you remember we did this experiment some time back, we'll discover that the oil will be floating on the surface and the water will be at the bottom. So they don't mix even if you stir. These ones are referred to as immiscible liquids. Immiscible liquids. So we have miscible liquids and immiscible liquids. Let's look at more discussions on the different types of mixtures in our next segment.